Hello everyone, Juicebags here, and welcome back to a little Minecraft Tekkit. We are about to create some serious power generation and a little bit of absolutely awesome nuclear badassery. So let's leave the juice tower behind, as I don't want to be messing with this stuff up in my crib. So I'm going to head on over to this platform here, which I've shown before, which is going to be kind of my nuclear testing facility. Now, is it not all loaded? Yeah, it's not all loaded. Derp. There we go. Loading a little slow. I'm sure this monstrosity that we're about to create could potentially cause a little server lag. So I'm not sure how often we will actually run it. But as everyone knows, I've been working a little bit with fission reactors. I want to start off there, start with the basics, and I want to remedy a few myths and kind of optimize a few aspects of the fission reactor. Now, everyone's seen the videos. What the majority of people are doing is creating a fission reactor that's kind of in a 3x3 area, like so. Popping the fission reactor down in the middle and then having the 9 turbines clicked into one big one running over top. Now, there's several problems with that design. The main one being it is just not taking advantage of the full potential of what this fission reactor can offer. Now, first things first, by operating the fission reactor at a decent temperature, you can actually increase... I should have grabbed some more hardened glass here, huh? I may not have enough. Let's see. You can increase the size of your water pool by 7x7, or I'm sorry, 5x5 instead of 3x3, like so. I'm using some of the leftover hardened glass from the dome up on the moon base. I figured we'd put it to good use here. You don't need to use glass, but it is handy for being able, because you can see through it, of course, being able to see exactly what's going on. Now, what we're going to do today is we're going to make this fission reactor. We're going to add some ultimate badassery to it, and we are going to make it so my number one complaint with the fission reactor is the fuel rods just don't last long enough. According to the wiki, they last 30 minutes, which doesn't seem like enough bang for the buck. However, I found a way to extend that to almost double the amount of time one Fissile Fuel Rod will last before it's depleted. So let's go ahead and jump on forward. Alright, so first things first, I'm going to just create a little unlimited water supply over here, which we're going to use to fill up the fission reactor once we get things going. So we're going to pop some water in there. We're going to pop some water in there. And now we've got our unlimited water supply, so we can go ahead and get that reactor filled up as needed. Now, a few things we're going to need to make. We're going to start off, we're going to make our 5x5 square, like so. That's enclosed. Dead center in the middle of that, we're going to go ahead and knock out one block. And we're going to drop down a thermometer. Now, where is my thermometer? There it is. To make the thermometer pretty darn easy. Where'd it go? It's going to be 8 steel ingots on the outside with a handheld thermometer in the middle. The handheld thermometer, of course, is just going to be 3 steel ingots at the top, 1 bottom center, 4 bits of glass, and a basic circuit in the middle. So let's go ahead and pop that thermometer down right in the center, like so. Now our actual fission reactor is going to go directly above that. Now to make the fission reactor, it's going to be 4 steel plates, 2 advanced circuits, 2 pistons, and an empty cell in the middle. It's going to get you the fission reactor. Let's pop that bad boy down right there. And now we're going to make ourselves just a little bit of room. So let me go ahead and knock away some of these guys here. Let's just go ahead and hollow out the entire 5x5 area to give us some room to work, as we're going to have to go down underneath that thermometer and get things set up. Now, next to, it doesn't really matter which side, but somewhere directly in the block next to the fission reactor, we're going to knock one block out, and we're going to take our sticky piston and put it like so. Now, directly above the sticky piston, we're going to have a control rod. Now, most people are familiar with these guys. It provides some basic protections versus overheating of your reactor. Now, the reactor itself starts taking damage when it gets above 1800 degrees, and it will blow up, spewing madness everywhere at 2000. Now, the whole point of the control rod is to remedy this situation. However, what happens is we actually want our thermometer set at 1800 degrees, because we know over 1800 it's going to start taking damage. So how that's going to work is when the reactor gets to 1800 degrees, the control rod is going to pop up and control the reactor. It's going to shut it off. Now, what's going to happen the second that thermometer drops below 1800 degrees, it's going to disengage that fuel rod. I'm sorry, that control rod. Now, that's basically going to keep this piston just shooting up and down over and over again. And although it is effective and it does work, to maintain our Fissile Fuel Rods, to make them last a little bit longer, we want to make some slight changes to this. So this is what we're going to do. Let's go ahead and knock out one more level below. Knock out directly below that as well. And let's get out the old Rednet cable. Now, the Rednet cable, if you put it directly underneath, as you see, it's going directly to the sticky piston. This, by itself, with no other sources, will control your fission reactor and make sure that it doesn't overheat. However, that's not how we want to do it. What we want to do is, I done went and reset my thermometer, so let's go back through and get it back to 1800. Dang it. Oh my, oh my. Try this again here. There we go. Now I'm going to keep constant daylight on during the course of this tutorial. What we want to do is we want to come directly out of the side of the thermometer, like so. We can go ahead and go down underneath it then. Now, what we're going to do next is, instead of going directly over to our sticky piston, we're going to bust out the old Programmable Rednet Controller. The Programmable Rednet Controller is made with 2 redstone up top with a diamond in the middle, 2 bits of lapis, 1 gold ingot, 2 sets of plastic sheets, and a Programmable Rednet Controller housing. The Rednet Controller housing is just 4 plastic sheets on the outside, 1 iron ingot on the bottom center, glass in the middle, and 3 bits of redstone. We're going to go ahead and pop that bad boy down let's whoops. Let's pop it down like so. Now we can go ahead and take our RedNet cable. We're going to run it out of that and then over to our sticky piston. Now, the reason we're going to do this is there's just a bazillion amount of features that the Programmable Rednet Controller can do. The one we're interested in is the pulse lengthener right here. Now, how we want to set our pulse lengthener up, you see there's lots of different, we'll just go ahead and start fresh, just as if I just laid it down. So we're going to go down to the pulse lengthener setting. Okay, now the left side over here is your input controls. The right side is your output. So we are input output the D, U, F, B. That stands for down, up, front, back, right, and left. Now, as we're coming into the left side of the controller, we want that set to left. Now, if you also notice, there's a little white band right around where this RedNet cable is coming out. What that is going to do is correspond to this color, which is white. As you see, you can change that, and that is the different channels that are available using the Programmable Rednet Controller. The PRC is pretty badass. Now, what we want is two requirements for this to work. One of them we're going to set as a constant. We're going to bump this up as far as we can get it, which I think is going to be 240. If you hit your middle mouse button, yeah, it's well, maybe we can even get it a little bit higher. Let's see. If you hit your middle mouse button, it goes up by 16, and you don't have to keep. Yeah, we can get it. How high will it go? 240, 250, 55. All right, 255. Actually, you could just right-click it once, and that will take it to 255. 255 is going to be about 12 seconds, I believe. So what this is going to do, we're going to go over to the output side now. Input, output, and this is going to be right. So the R, it's going to tell this RedNet controller that when a signal comes into the left side, it's going to put out a constant signal for 255 ticks, which, like I said, is about 12 seconds. Now, what that is going to do now is when this control rod shoots up, it's going to stay up for 12 seconds, and that's going to allow the reactor to cool down to right about the 1200 degree range, 1000 to 1200 degrees, before it disengages and turns that back on. And the 1200 to 1800 degree range is kind of the sweet spot of where we want our reactor to operate for the maximum amount of steam efficiency. So let's see, do I have plenty of glowstone bricks? Let's throw some glowstone in the mix down here just to fill these gaps in a bit. How do I want to do it? Let's do it like this. We're going to fill all these gaps in. I'm using the glowstone brick just so it illuminates the area a little bit, makes it a little bit easier to see. And now we're ready to start dumping some water. So basically what we need to do at this point is fill this entire area so that it's no longer running water. So let's go ahead and get both of our buckets on our bar, go over to our unlimited water supply, and get these guys all filled in. Of course, if you grab more buckets, this process will be a lot quicker. But we basically just want to create a still pull inside of where the reactor is going to operate. So I'm going to go ahead and get these filled up and jump right on forward. Alright, so now we got that all filled in a still pull. Now before I go any farther, I want to give credit where credit is due, and that is special thanks to Jakalth on the Technic Forums, as he's got quite a bit of information, tips and tricks on the atomic science mod posted up over there on the forums. There's a lot of good reading there, and his post is really what gave me the inspiration to attempt to get this done. Now, we're all set. We could throw a Fissile Fuel Rod into that reactor right now and get this thing pumping. We could throw turbines directly above this water here, throw a Fissile Fuel Rod in there, and we would be 100% good to go. However, that is not the route we want to take. First things first, let me create a little access port right here. And what we're doing here is we're creating an area where we can access the reactor to put the rods in and out and check out the reactor status. That also allows us to see, although it's partially blocked, you can see the temperature down there on the thermometer, which is also good information. Now, instead of just throwing the turbines directly above here, it's time to bust out Mr. Steam Funnel, which is greatly underappreciated, and it's completely insane the amount of benefit it adds to any of them, not just the fission reactor, the fusion reactor as well. We're going to take 25 steam funnels. The steam funnels are made ridiculously simple with either iron or bronze, like so. We'll give you 2 of them. So easy to come up with a bazillion of these guys. Let's go ahead and throw them all in. The steam funnels are going to allow us to pipe our steam. Now, how the fission reactor works, for those that do not know, is it uses a Fissile Fuel Rod to heat up, which in turn heats the water and produces steam. Now, the steam, of course, rises and will spin turbines, which we could put turbines directly above. However, we're not going to. Let's get a little daylight again here. Now, as you see, I've got 5 stacks of turbines made. The reason being, everyone knows how the turbines work. You throw 9 turbines down, like so. You right-click them with your wrench. You have to get the wrench selected first. And it's going to then turn into a larger turbine. Now, in older versions of Tekkit, this larger turbine actually produced less than the 9 individual turbines. That is no longer the case, so by all means, go ahead and turn it into the big one. Although it's not a huge amount of efficiency higher, it is more efficient than the 9 individuals. Okay, now what we are going to do instead is we're going to get some liquid duct, and we are going to liquid duct all this steam into some piping. How awesome is that? Now, we want to turn all of these bits of liquid duct so that the arrows are facing upward. Now, by doing this, we're going to require a redstone signal. That comes next. Let's go ahead and get all these guys popped up. And for all the ones in the middle, just hop up top. You don't actually have to hit directly where the joint is being made. Whoops. Did I get them all? Up, 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 up. They're all up. Awesome. Alright, now we're going to need to let's come off the side here. Over and down all the way to the ground. We're going to do the same thing on this side. So now, oops, I was supposed to come out. I tried to make this symmetrical. That's what, if you notice the glowstone blocks, the glowstone bricks on the ground, that is to help me to make this symmetrical, as that is not my strongest point. As everyone has seen my creations in the past, they usually end up requiring quite a bit of cosmetic work afterwards. Now, we don't want to get a signal set up quite yet, but we're getting close. Now, now that we're capturing all the steam in the liquid duct, we need to create a little field, a little grid of liquid duct that's going to be 13 blocks by 19 blocks. It doesn't matter which direction or which way it's facing. It just needs to be 13 by 19. Can you guys sense the badassery en route? Oh, it's coming, I assure you. Alright, once we get our basic outline of our liquid duct grid, we can go ahead and connect it up. And do you guys see where I'm going now? We're going to go ahead and every third, we're going to go ahead and run another span of liquid duct across the edges. Looking good. I'm not sure when the steam funnels were added, but the steam funnels add just a ridiculous amount of efficiency to your reactors. The reason it is it concentrates that steam. It allows them to run the turbines to spin longer after the reactor is shut off. And as you see with what our finished product is going to end up being here, it allows you to increase the energy generation from your reactor by such an enormous amount. Okay, now we're going to go every third, and we're going to have one going up. Now we're going to do this on every one of these posts. So I'm going to go ahead and get that done, and we will jump forward to that point. Alright, so we've got our field of liquid duct in place. Go ahead and give you an overview here so you can see what this looks like. Once again, that's 13 blocks tall by 19 blocks wide in this setup. 13 by 19 in any configuration is going to work out just fine. Alright, now to the fun part. We're going to be able to produce so much steam out of this 5x5 area with one single fission reactor. You ready for this? We're going to be able to have 35. That's right. 35. 3, 4, 5. Yep, 35 large reactor turbines running off of one single fission reactor. Is your mind completely blown or what? Check this out. We're going to go ahead and lace this entire area with our 5 stacks of reactors, or of turbines. We're going to convert all these guys into big turbines, and then we're going to have 35 reactor turbines spinning off of one single fusion reactor. I'm not sure what the math is. Jakalth, I think, did the math on the forum post, but it was like it increases the output of one single fission reactor by like 1,200 or 1,500%. So, I mean, how completely insane is that? So we're going to go ahead and lace down these guys. So we got one row done there. Let's go ahead and convert all these to the larger turbines by using our wrench on the center of each 3x3 set. Wow! What do you think? Now I'm going to go ahead and get all the rest of these turbines. There's quite a few. I'm going to get all these guys laid down. Then I'm going to throw some redstone energy conduit coming up and out of these guys. And then we'll take a look at the ridiculous amount of power that this is able to produce. This is so insane, in fact, that once I get the reactor automated a little bit more, I'll definitely be providing power to everyone on the server. And no, you'll know if you play on this server, you will not have to create a power generator. All you're going to have to create is energy tesseracts, and you can suck as much juice as you want because we're going to be creating a ridiculous amount. So let me go ahead and get the rest of these turbines laid down, and we'll jump on forward to that point. Alright, so we have got all of our turbines placed. I've got redstone conduit coming out of all of them. Look at this. We got a field of turbines here. How awesome. Now, it's important to note also, make sure you got the proper output set on your output out of the redstone conduit, energy conduit. When you first put it on, it's going to be facing inwards. So you need to go through, right-click all those with your wrench, and let's see. Do I want this to be a complete pain in the butt? Yeah, I don't want to take up the additional height. So I'm going to go ahead and connect all this redstone energy conduit. In fact, we don't need it connecting that way. We can go with just connections down around the exterior and then down each row. So let me go ahead and get that done, and then I'll show you guys what it looks like. Alright, so we're back. I've got all the redstone energy conduit placed. I've got all of my directional arrows pointed up. So we've got the export of power. And I found something out really, really cool in the process. I'm not sure if it's a side effect of the radiation or what it is. But check this out. I brought along a couple of empty redstone energy cells. That way I could slap them on and test how much power we were coming up. And I noticed that my redstone energy cells that were empty were like half full. They're not even connected to anything. They're in my bag. So check this out. Redstone energy cell. You see that? The charge is going up. 33,837, 34,837. Not even connected, sitting in my inventory. This monstrosity is going to be such a massive power creation that's creating power without the reactor even running, without the turbine spinning. Look at that, 38,512. Now, obviously, it's not much, but my God, we're creating power with nothing going on. Now, obviously, before you get to this point, you're going to realize that this is one seriously massive resource hog. Now, everyone that plays Tekkit knows that you get to a point where you basically have unlimited supplies through all the automation, quarries, and such. We're to that point on the server, so I can waste resources like this. Not an issue. But this is what it looks like at this point. Now we are all ready to go with a couple of exceptions. Still need to throw a Fissile Fuel Rod into our reactor. And then remember I said that these liquid ducts here were going to need a redstone current. So you can do that a lot of different ways. I am just going to use blocks of redstone. And I'm going to give all of these outputs a redstone signal. And it looks nice. Nothing like a block of redstone to brighten your day. So here is our finished reactor in all its glory. I told you there was going to be some badassery involved, and indeed there was. So let's go ahead and pop this Fissile Fuel Rod in, get this bad boy heated up, and see how it performs. Now, I got the control rod on this side, and it's blocking my view of the thermostat, which you can move it wherever you want. I did that because I wanted to be able to see the control rod actually going up and down. But let's go ahead and throw this bad boy in the reactor, and you see the on our thermometer there, the temperature is indeed increasing. Now, when it gets to 1800, I want to test and make sure that it is indeed shutting off for 12 seconds. But holy shit! We got 35 full-size reactor turbines spinning off of one fission reactor. Oh yeah, that is exactly what I'm talking about. Now, everybody knows how I play Tekkit. I get a little carried away, and God knows this is really a little carried away. But does this not answer some serious power questions? My only concern right now is testing out my control rod setup. So I want this to get up to its 1800 degrees. See, it's at 700 and change right now. That way we can see. I want that control rod to come up, stay up for 10 to 12 to 15 seconds, whatever, and then go back down and get this bad boy going again. Now, as soon as this thing gets over, say, like 12 or 1300 degrees, I'm going to go ahead and pop one of these redstone energy cells up here and see just how ridiculously screaming fast these things are charging. So I'm going to need to come off of it with a little bit of redstone, as right now all of the outputs, see, let's do that. Let me check my temperature here. Let's get a little daylight going again. Check the temperature out here. Alright, it's at 1200 degrees, so that's good enough for me to start doing some testing. I want to see this redstone energy cell just scream. Oh yeah. Holy shit. Would you look at the amount of power being produced here? We're already have created 100,000 MJs just in those couple of seconds since it's been popped up. At this rate, it will completely fill a 600,000 MJ redstone energy cell. I'm guessing in like 30 seconds maybe? And the only reason it's only... See, here's the great part. Let's go ahead and let's branch off this a little bit more. Or you know what? Let me do this. I'm going to pull that down. I'm going to come out one more, and I'm going to make a little T here. See, the reason it's only going that fast is because the redstone energy cells can only accept 100 MJs per tick coming in. You see, we got 2 redstone energy cells. Oh yeah, they're both screaming. I don't know what the limit is. I'm thinking we could probably put 20 empty redstone energy cells here, and they're going to be collecting power this quick. We are creating a buttload of power, and I mean a buttload. So let's check it out. We're at 1600. I'm going to have to lower my temperature. We're too efficient in the cooling right now, and we're not actually heating up enough. I wanted this guy to get up to around 1800 degrees. We're at 1600 now. So let me go ahead and lower it. Let's see if we can get it lowered to 1600 and let it cycle on and off then. And that'll help save that Fissile Fuel Rod. Oop, I yanked out my Fissile Fuel Rod by accident. Let's get that bad boy back in. Is it going up again? Alright, and let's get this set at 1600. Did that get it? Nope, it's still at 1800. 1600, there we go. So the thermometer there is set at 1600. We're getting close. I want to see that control rod pop up for about 10 seconds. We're actually providing so much cooling, I think, sucking all the steam out like this, that the reactor's running very, very cool. See, 1584. It's bouncing around there. It's trying to go up. I'll find the sweet spot. I'll just let this bad boy run. There we go. So it popped up. That's about 10 seconds. And down it goes. Awesome. That dropped it down to 1500 degrees. So it's going to bounce between 1500 and 1600 degrees, which is super, super safe. It's well in that safe zone. We shouldn't have to worry about any overheating, any explosion. This is awesome. This is I didn't test this. This is all theory, and it is performing exactly how I pictured it. Let's check on these redstone energy cells. Oh yeah, still screaming on up. Look at it just ticking off. With my current setup with the magmatics or with the biofuel, in fact, we'll run over there and do a test. We see how fast these guys are creeping up. Let's run on over and test out how fast one will go up. I think I got some more that are at halfway or whatever in one of my bags. Let's see, I think it's in my big white backpack. Yeah, let's grab this one here. Let's go pop this up to... Whoop. We got some loading issues here today. Let's pop this up to the magmatics first and compare it just by looking at it and see... wow, we're definitely got some bad chunk loading issues. The last update, I haven't reloaded Optifine, so I don't have the multi-chunk loading capability right now. Or the multi-core chunk loading capability, pardon me, that you get with Optifine. So I'll definitely have to pop that back in before I do my next video. But let's take a look at it with the magmatics here. Let's pop that bad boy on there. And see where... Well, actually, you can't even compare it to that because it's the maximum input. So that was kind of a wasted trip. But there is the juiced version of a fusion reactor in all its glory. Let's go back over and take one more look at that bad boy. Oh, man. Now, what I can picture out of this facility... Wow, I should have got Optifine hooked back up before I got this video going. What I can completely picture from this facility is it being an enclosed building with another floor, and just have a massive area up top as a charging station for anyone to throw down their redstone energy cells, and then also as a tesseracting station where you can throw your tesseracts up there. Now that's still yet to be built, but there it is, the juice bags version of a fission reactor. 35 full-size turbines screaming. So thanks again for watching. Click that like button. Please subscribe to the channel, and hope to see some of you guys on the server here soon. Gonna have some fresh faces coming in here within the next couple of days, as we've got a few more people whitelisted. But thanks again for watching. Hang in there. There will be more slot openings in the future. But wow, I'm still just saying wow because I'm just amazed. This is just so awesome. So thanks again. Click that like button. Please subscribe. More Tekkit coming soon.